Hello and welcome to this clip looking at a structured KW and delta newt H question from the autumn 2021 Physical Chemistry OCR Chemistry A paper. So it starts off asking about sodium hydroxide, and it asks you to calculate the pH of 0.140 mole per decimeter cubed NaOH at 298 K. So from the data sheet, the ionic product of water is 1 times 10 to the minus 14. And you can plug that into Kw equals H plus times OH minus. So in the question it tells you sodium hydroxide is a strong base, which means it completely dissociates, which therefore means we can take 0.140 and apply that to the concentration of hydroxide ions. So now we have two of the three numbers that we need. We're looking for the H plus concentration, so we simply rearrange the equation and sub in the numbers that we know, which gives us 7.14285, 3 times 10 to the minus 14. I put that into minus log and to get the pH value, and that gives me 13.14612.804, but they want it to 2 decimal places, so you put in 13.15. Quick check of the mark scheme shows that we're on the right track. The next part is a delta newt H question involving a practical where two solutions are mixed and they neutralize one another. So starting with the two solutions and getting the actual number of moles of each, you need to show that sodium hydroxide is in excess. So looking at the values, you can see that 0.0825 is the sodium hydroxide. So looking at the equation, 0.04 moles of H2SO4 will need 0.08 moles of NaOH. We have greater than that amount, so therefore we have NaOH in excess. So in the mark scheme again, the two calculations get 1 mark, and justifying why the sodium hydroxide is in excess using the information is the second mark. So the third part of the question is to calculate the enthalpy change for equation 22.1, which we can just quickly remind ourselves of. And it's obviously going to be Q equals mc delta T. And starting off, it asks us to assume that the densities of all solutions and the specific capacity of the reaction mixture are the same as for water. So from the data sheet for OCR, C is 4.18. And from the earlier part of the question, it says the temperature increases by 13 degrees. So adding the two volumes together and converting it into grams, you get 80 times 4.18 times 13, which gives you 4.3472 kilojoules. Now, to work out the delta H1, you take the minus Q value in kilojoules and divide it by the moles of H2SO4. So that gives you minus 108.68. So delta newt H, if you remember, is based on number of moles of water made from reacting an acid and a base. So looking at the equation again, you can see that the number of moles of NaOH is equal to the number of moles of water. So therefore, delta newt H is going to be minus Q over the number of moles of H2O, which gives you minus 4.472 over 0.08, which equals 54.34. And delta newt H happens to be around minus 57 kilojoules per mole. So it's actually quite useful to remember this, so you can double check against the numbers that you get when you do these types of calculations. So checking against the mark scheme, first mark is for the number of joules or kilojoules, second marks for calculating minus 108.68, third mark is for delta newt H, fourth mark making sure it's negative. So finally, it asks you to project the increase in temperature when two new quantities of H2SO4 and NaOH are actually mixed. So the first thing to do is take the original quantities and compare the two in terms of the number of moles. So revisiting the moles we calculated before, and now pushing in the new values, you can see that the number of moles are actually doubled in each case. So if you have twice the moles, that's going to generate twice the energy when reacting. And on its own, that would mean an increase in delta T, assuming the same volume. But the volumes are also doubled. So what you've got to remember is if twice the energy is spread over twice the volume, delta T must remain the same. So therefore the temperature change doesn't change. So it still remains at 13 degrees is what I'm saying. Okay, so hopefully this takes you through the question and gives you a few ideas about how to approach this type of question in future. Thanks for listening. Until next time, see you soon.